Light absorption, reflection, and transmission. We have previously learned that the visible light wave consists of a continuous range of wavelengths or frequencies. When a light wave with a single frequency strikes an object, a number of things could happen. The light could be absorbed by the object, in which case its energy is converted to heat. The light wave could be reflected by the object, and the light wave could be transmitted by the object. Rarely, however, does just a single frequency of light strike an object. While it does happen, it is more usual that visible light of many frequencies, or even all frequencies of frequencies, or even all frequencies, is the incident towards the surface of the object. When this occurs, objects have a tendency to selectively absorb, reflect, or transmit light certain frequencies. That is, one object might reflect green light while absorbing all other frequencies of visible light. Another object might selectively transmit blue light while absorbing all other frequencies of visible light. The manner in which visible light interacts with an object is dependent upon the frequency of light and the nature of the atoms of the object. In this section of Lesson 2, we will discuss how and why light of certain frequencies can be selectively absorbed, reflected, or transmitted. Visible light absorption. Atoms and molecules contain electrons. It is often useful to think of these electrons as being attached to atoms by springs. The electrons and their attached springs have a tendency to vibrate at specific frequencies. Similar to a tuning fork or even a musical instrument, electrons of atoms have a natural frequency at which they tend to vibrate. When the light wave with the same natural frequency impinges upon an atom, then the electrons of that atom will be set into vibration motion. This is merely another example of the resonance principle introduced in Unit 11 of the physics classroom tutorial. If a light wave of a given frequency strikes a material with electrons having the same vibrational frequency, then those electrons will absorb the energy of the light wave and transform it into vibration motion. During its vibration, the electrons interact with neighboring atoms in such a manner as to convert the vibration energy into thermal energy. Subsequently, the light wave with that given frequency is absorbed by an object, never again to be released in the form of light. So, the selective absorption of light by the principal material occurs because the selected frequency of the light wave matches the frequency of the electrons in the atoms of this material vibrates. Since different atoms and molecules have different natural frequency or vibrations, they will selectively absorb different frequency and visible light. Visible light reflection and transmission. Reflection and transmission of light waves occur because the frequency of the light waves do not match the natural frequency of vibrations of an object. When light waves of these frequencies strike an object, the electrons in the atoms of an object being vibrated, but instead of vibrating in resonance at a large amplitude, the electrons vibrate for a brief period of time with a small amplitude of vibration. Then the energy is re-emitted as a light wave. If the object is transparent, then the vibrations of the electrons are passed on to the neighboring atom through the bulk of the material and re-emitted on the opposite side of the object. Such frequencies of light waves are said to be transmitted. If an object is opaque, then the vibrations in the electrons are not passed from one atom through the bulk of the material. Rather, the electrons of the atoms on the material's surface vibrate for a short period of time and then re-emit the energy as a reflected light wave. Such frequencies of light are said to be reflected. Where does color come from? The color of an object that we see is largely due to the way these objects interact with the light and ultimately reflect or transmit it to your eyes. The color of an object is not actually within the object itself, rather the color of the light that it shines upon it and is ultimately reflected or transmitted to your eyes. We know that visible light spectrum consists of a range of frequencies, each of which corresponds to a specific color. When visible light strikes an object of specific frequency, and a specific frequency becomes absorbed, that frequency of light will never make it to your eyes. Any visible light that strikes the object and becomes reflected or transmitted to your eyes will contribute to the color appearance of that object. So the color is not the object itself, but the light that strikes the object and ultimately reaches your eye. The only role that the object plays is that it might contain atoms capable of selectively absorbing one or more frequency of light, of visible light, that shine upon it. So if an object absorbs all the frequencies of visible light except the frequency associated with green light, then the object will appear green in the presence of red, orange, yellow, green, blue, indigo, violet, or Roy G. Biv. And if an object absorbs all of the frequency of visible light except the frequency associated with blue light, then the object will appear blue in the presence of Roy G. Biv. Consider the two diagrams below. The diagrams depict a sheet of paper being illuminated with white light, Roy G. Biv. The papers are impregnated with a chemical capable of absorbing one or more of the colors of the white light. Such chemicals are capable of selectively absorbing one or more frequency of light, as known as pigments. In example A, the pigment in the sheet of paper is capable of absorbing red, yellow, blue, indigo, and violet. In example B, the pigment in the sheet of paper is capable of absorbing orange, yellow, green, blue, indigo, violet. In each case, whatever color is not absorbed is reflected. Check your understanding of these principles by determining which colors of light is reflected by the paper and what color will appear to an observer. Transparent materials are often that allow one or more of the frequencies of visible light to be transmitted through them. Whatever color are transmitted by such objects are typically absorbed by them. The appearance of a transparent object is dependent upon what colors of light are incident upon the object and what colors of light are transmitted through. The colors of the perceived object are the result of the interaction between the various frequency of visible light waves, and the atoms of materials that objects are made of. Many objects contain atoms capable of either selectively absorbing, reflecting, or transmitting one or more frequencies of light. The frequencies of light that become transmitted are reflected by our eyes, will contribute to the color that we perceive. Sometimes it isn't enough just to read about it. You have to interact with it. And that's exactly what you do when you use this Physics Classroom Interactive. We would like to suggest that you combine the reading of this page this page with the use of our Stage Lighting Interactive. The interactive is found in the Physics Interactive sections of our website and allows learners to explore the appearance of actors upon a stage when illuminated with varying combinations of red, green, and blue light. Check your understanding. Natural philosophers have long pondered the underlying reason for color in nature. One common historical belief is that colored objects in nature produce small particles, perhaps light particles, that subsequently reach our eyes. Different objects produce different colored particles, thus contributing to the different appearance. Is this belief accurate or not? Justify your answer. What color does a red shirt appear when a room light is turned off and the room is entirely dark? What about a blue shirt? A green shirt? The diagrams The diagram depict a sheet of paper illuminated with white light. The papers are impregnated with a chemical capable of absorbing one or more of the colors of the white light. In each case, determine which colors of light are reflected by the paper and what color of the papers will appear to the observer. The appearance of a transparent object is dependent upon which colors of light are incident upon the object and which colors of the light are transmitted through the object. Express your understanding of this principle by determining which colors of light will be transmitted and which colors and the color of the paper will appear to the observer.